solving this past paper. So this is of May 2023. In part A to part D, you will investigate the number of triangles formed in each stage. Click on each stage to see how the number of triangles T increases. So this is how the number of triangles is essentially increasing. So there is a large square or a rectangle. Inside of it, there is um, a rhombus type of a shape, which includes one square and one rectangle and four triangles at the corners, and so on and so forth. It just increases, right? Okay. So question number 7, part A asks us, write down the missing values in the table up to row 6. So we had 0 to 8 and 8 to 16 and 16 to 24. So the next values are definitely going to be 32 and 40. Reason being is that there is an increase in 8 values in each case. Hence, that's why we get this answer. Alright. Then it says, describe in words two patterns in the table for the number of triangles T. So we can say, first things first, as a term to term comparison, as the stage n increases by 1, number of triangles increase by 8. Another pattern can be all numbers are even numbers. Another pattern can be all numbers are products of 4 and consecutive odd number. Now, what do I mean by that? 0 can be written as 4 times 0. Sorry, not consecutive odd numbers, consecutive even numbers. So 4 times 0 is 0. 4 times 2 is 8. 4 times 4 is 16. 4 times 6 is 24. 4 times 8 is 32. And 4 times 10 is 40. So what's essentially happening? The even numbers are basically piling up with each other, and they're being multiplied with 4 to give us the total number of triangles. Does that make sense?
Yeah.
That's great. Write this down.
Wrote it all
I
down.
Okay, that's great. Now the next part says, 7 part C says, um, write down in simplest form a general rule for T in terms of N. So the sequence was 0, 8, 16, 24, 32, 40. So here we can see that there is a common difference of positive 8 and the principal term of A that is equal to 0. So we have A plus n minus 1 multiplied by D. A is 0, n is we don't know, and 8 is D is 8. Common difference is 8. So we have 0 plus 8n minus 8. 0 does not make or break anything. So essentially speaking, 8n minus 8 will be our final answer. That would work. Write this down and also at the same time do test these values. The next part says, well, verify your general rule for T. So verification of course is done for what has not been given to us. So let's just select the values 2, 4 and 6. So when you might have done it, 8 times 2 minus 8 gives us the value of 8. 8 times 4 minus 8 gives us the value of 24. 8 times 6 minus 8 might have given the value of 40. So we can say hence these values match the ones provided in table. Thus, general rule is verified. Alright, so you have to write this statement at the end. Moving to part um, E, we are being told that the simulation below shows how smaller rectangles are formed. Each time the dimensions of the rectangle are halved, the new rectangle is centered inside the previous one. So we can see that, right? Interact with each stage to see how the rectangles are formed. So have a look at this stage. If the value of the length is 1 meters, the value of the width is the half of it. If this is 1 over 4 meter, the value of the width is 1 over 8 of it. So basically, it's being halved. So there is a pattern being followed. Okay. So show that 1 over 4 multiplied by 1 over 8 is 2 raised to the power of negative 5. I told you, and this is a general rule that we have studied, that whenever we see negative powers, what's the first thing we do? The first thing we do is that we introduce a fraction. We make 1 the numerator, and whatever present was there, we make that the denominator, except for the negative part. Then, if you want to further solve it, we get 1 over 2 raised to the power of 5 gives us the answer of 32. 1 over 4 multiplied by 1 over 8, the numerator remains 1 as it is, and 8 times 4 gives us an answer of 32, and thus that is our correct answer. Makes complete sense, right?
Yeah.
That's great.
I've written this down.
All right. Then comes this part of 23 marks. First things first, we are being told to. mm, all right. So investigate the values in the table to find a relationship for the area of the rectangle in terms of n. So talking about the width first, the length first. So you see, what's essentially happening in this case? What's happening is that the values are simply being divided by 2. So 2 divided by 2 gives us 1. And you further half it, you get 1 over 2. And you further half it, you get 1 over 8. And you halve it again, you get a 1 over 8. And then you divide that by 2 again, you get 1 over 16. The width. What about the width? So once again, it's being halved in each and every stage. So this becomes 1 over 16, and this becomes 1 over 32. The area is essentially length times width, right? So in order to find the area in stage number 5, we should do 1 over 8 multiplied by 1 over 16. So 16 times 8, I think it is 128, right? I think it is 120. Now, how would we write 1 over 28 in index form? Now, that's a bit complex. But if we were to notice the pattern here, you're going from 1 to minus 1, so that's basically a decrease in 2. Then you go from minus 1 to minus 3, a decrease in 2 again. And you then go from minus 3 to minus 5, there is a decrease in 2 again. So essentially speaking, here you should be decreasing by 2 yet again, right? You'll go from 2 to minus 7. Make sense?
Yeah.
That's great. This is a new question and I like this. Then you have the area of rectangle at stage 6. So you have 1 over 16 multiplied by 1 over 32. I think 32 times 10 is 320, and 32 times 6 is 192. If we add both of them together, we are supposed to get, I think, an answer of 512. Please do verify it. Is it 1 over 512?
Yeah.
That is okay. And that's supposed to be 2 raised to the power of negative 9. The pattern remains same. Describe in words. Describe in words a pattern for the table for area of rectangle. Okay. So we can clearly see that the area of the rectangle is basically decreasing by 4. Not decreasing by 4, it's a successive area in which it is being divided by 4. So if you were to divide 2 by 4, you would get an answer of half. If you were to divide half by further 4, if you apply the KCF method, you get 1 over 4, which is 1 over 8. So we can say that each successive area is 1 by 4 of previous area. So that's the pattern for the area of rectangle. Then it says write down in simplest form a general rule for A in terms of N. Okay, this is a bit confusing. Have you written the pattern for area first?
Yeah.
Okay. Talking about the general rule for A, we can effectively see, first things first, that looking at the exponents of base 2, we are going from 1 to negative 1, and then from, so for example, when the stage is 1, the index is 1 as well. But when the stage is 2, it's minus 1. When the stage is 3, it's minus 3. 4, minus 1. So what's happening essentially? The exponent forms an arithmetic sequence with the first term 1 and the common difference of minus 2. Okay? So when the common difference, and essentially speaking, the common difference can be written as n minus 1. So we have 1 minus, the first term is 1a, and the common difference is of negative 2. So we have 1 minus minus 2n. Sorry, this is plus, my bad. Plus 2. Minus 2n plus 2. So we have 3 minus 2n as the exponent. But the difference is that we are doing this with reference to the index. What about the power? So essentially, sorry, what about the base? Essentially speaking, this 3 minus 2n, it is another way to write the general rule in terms of the base. What happens essentially? We have a remaining base of 2. So the general rule remains 2 raised to the power of 3 minus 2n. Makes sense, right?
Yep.
Good.
I wrote that down.
All right. Then we have to test and verify our general rule. So let's just do it. In order to test and verify our general rule, mm, let's substitute the value of n equals to 2. So we get 2 raised to the power of 3 minus 2 times 2. So we get 2 raised to the power of 3 minus 4, which is 2 raised to the power of negative 1. And here you go. Our rule is tested. For the verification part, let's substitute n equals to 6. So 2 raised to the power of 3 minus 2 raised to the power of 6. We get an answer of 2 raised to the power of 3 minus 12, which is essentially 2 raised to the power of negative 9. And here we go, our answer is proven. So that's how, essentially speaking, we get the right answer. I hope that is clear. That's very easy. Do this so that we can solve the justification part. Done writing?
Yeah.
All right. Now we have to solve the justification part. How do I justify my answer? Look, um, justify your general rule for A, for the area. Okay. Area is essentially length times width, right? So in order to find, let's find the general rule for length first. That can be written as, um, wait a second. So the common difference was 1 over 2, which is 0.5, as it is like the next term divided by the previous term. So that was the common difference. So in order to find that length at any given stage, the formula that we can use was 2 raised to the power of 2 minus n. How did I reach to that conclusion? Have a look. 2 raised to the power of 2 minus n can be written as 2 raised to the power of 2 divided by 2 raised to the power of n. As what's essentially happening is that since we know that there is a division sign in between, which means that the base remains same and there will be a subtraction in between. We understand this, and this is something that we had learned in indices. Now, in order to verify this, let's do it. Let me substitute the value of n as 2, or let me substitute the value of n as 1, for instance. So if I substitute n equals 1, I get 2 raised to the power of 2 minus 1, which is 2 raised to the power of 1. That gives me an answer of 2. And here we go. I get an answer of 2. If I substitute the value of n as 0, sorry, not 0, in fact 2, as that's stage 2, what answer does this give me? 2 raised to the power of 2 minus 2, which is 2 raised to the power of 0, and anything raised to the power of 0 should be giving me an answer of 1. And here we go. Stage 2 gives me an answer of 1. So for the length, we have communicated effectively that our equation is going to be 2 raised to the power of 2 minus n. We agree on this point, right? After that, what do we do? When we solve for the value of length, what about the value of width? How would we solve it for that value? Let's have a look. For the value of width, it's essentially it's dividing by 2 again, right? But the difference is that this time around, it starts from the base value of 1. So I can say 2 raised to the power of 1 minus n. And we can verify this as well. Now I know that area is the product of length and width. Area is the product of length and width. Let me just erase all of this. So if I want to find area, I should write it like this: 2 raised to the power of 2 minus n multiplied by 2 raised to the power of 1 minus n. Now, what do we know while solving questions like these? That when there is a multiplication sign in between, so the bases are going to simply remain same, but the powers are going to add up. So we have 2 plus 1 minus n minus n. So we have 2 raised to the power of 2 plus 1 is 3, minus n gives me an answer of minus 2n. And here we go.